So, alright guys, after figuring out that this is actually power supply issue, I decided to remove everything, like leave only power supply on the table. So today we, or as a continuation, we would like to double check the power supply. Look at this big Nikon capacitor. I hope it's not leaking because it's kind of look funky right here, but it's maybe just flux. I hope this is just flux. It's really hard to tell if it's leaking or not. But anyways, so it's a complex power supply. Look, I mean, I'm no expert in power supply. She's not gonna claim I am, but what I see here, so it's already discharged, so I'm handling it just like that. Oh, also I found someone actually was repairing power supplies. I couldn't find the service manual, but at least a person kind of measured on the working power supply voltages. So this is what you're supposed to get: +5, and this is for 4000 AD, LS 4000 AD scanners, but they usually share the same kind of topology and parts. It's a bit different because this main chip is supposed to be STR 6556, and here it's something else. Here we have STR F6553. So we have STR F6553. So this is the main switching controller. Okay, so it's like a MOSFET and a pulse width modulator controller in one package, which is kind of cool. Yeah. So I see here proliferation of Nikon capacitors. So clearly doesn't instill any kind of confidence in these capacitors, but we're gonna check them like a lot of electrolytic capacitors here. I don't see any obvious signs of damage. Yeah. Okay, so what are you gonna do? And by the way, this is not crazy powerful power supply, because look at this rectifiers. They're just tiny diodes, so they are not really beefy ones. Okay, so flyback diode right here. Oh yeah, okay, that's a beefy one right in here. Or those are rectifiers. Oh, what are those? Looks like they have more these ICs. I'm curious what are. Yeah, I wish I know. Had schematic of this power supply. Look at this. There's two more. I thought those are transistors. No, Siri Bob, they are not. And they look like on the low side, because this is the primary side here, right? Here's the insulation slot, and this is secondary side. So we could have two issues: something wrong on primary right here, including this controller that some people say that it may go bad, and we have secondary side. Okay, very interesting. So I have to Google this guy, take a look what it is and its pinouts, because it's not what I expected. It has only 5 pins, not what I saw with other chips. So that would be interesting. 5 pins, I see. And these guys are 5 pins. So 5 too. Yes, these guys. Let me write them down as well. These guys are, let me just unplug this. I think it's necessary here. SK3150J. SK3150J. I assume this is something 15 volt, and it's really hard to see. SK3120J. Okay, so that's 12 volt, probably. SK3120J. This is a weird. I see. What is that guy? This is transistor. We have one transistor marked as Q. So I assume this a transistor. There is no diode. So as far as diodes goes, over here, this and that, there is like one super mega beefy diode. That's pretty much it. And it's on secondary side. So this is diode. This is outputs of transformer. So I'm not sure about those middle pieces. See, this is double-sided load. So it's is it? Yes, it has some traces on this side. So technically, yeah, it's really hard. It would be really hard to say if there is any traces right in this, right in here in this mess. Yeah, I see some traces. So here's one trace going. Yeah. Okay, my friends. So what we have need to do actually is to quickly double check all all capacitors, because I mean there's a potential that some of the capacitors are Gonski, and there are quite a bit of them, starting with the big one. So let's just quickly go through them. Obviously, the big capacitor will be really hard. Let me do it again. Okay, so this capacitor is probably okay. Okay, so let's check this guy. Probably okay. Let's check this guy. Okay, let's check this big guy. Okay, so then we have two, okay, tiny one here. What about this guy? Okay, how about this guy? Oh, wait a second, is this capacitor kind of Gonski? Huh. Okay, so this is something going on here. Capacitor C19. Interesting. But we have a whole bunch more capacitors. If you see right there, I'm not even sure how to reach them. Okay, C16, I think this is the guy. Probably okay. Small value capacitors. There is one right here. I think this is capacitor. Yeah, good too. And there is a bigger one. I think this is the one. Okay, it's whoa. It's pretty low. Okay, it's a high value capacitors, but there is one just here. Okay, it's showing the same. What else we have tiny capacitor right here by this diode. Okay, this guy, I think. Oh, that's interesting. Has pretty high ESR. What is this? It's really hard to tell. 33 microfarad, 35 volts. No, definitely something wrong with this guy. Okay. We have to desolder this one and this one and take a look what's going on with them. And for that, I have new toy. Let's fire it up. Okay, that thing is up to speed, so let's desolder. Ooh. It looks like this is ground point and it's not cooperating. Okay, how about this capacitor? Wow. Is it good or something? What? Okay guys, took me some time to let me clean up those vias, those mounting pods. And it looks like there is nothing. Those are not so simple capacitors, turn out to be after all. Okay, so these are good. Yeah, it took me some time to actually get these guys removed. And I show you why. After I clean up all this. Yeah, it's looking kind of ugly, but... Okay. Alright, so it's really hard to show. Okay, maybe you can shut it down. I see this mounting point of the capacitor. Yeah, I mean, that's not looking nice, isn't it? And there is some kind of gunk around this mounting point of this capacitor right here. So, looks like our capacitor got leaky. So at least one of those. And these two guys are 33 microfarad, 35 volts. Yeah, Jamicons. Let me see what they show under test. Looks like I mix it up. No, it's better to use here. I mean, this one at least measures 33 microfarad, but it has 50 ohms ESR, which is really bad. Okay, this one. And this one, this is actually has some kind of gunk on the bottom. Let me see what these guys say. This one was measuring nothing. Okay, this measuring 19 picofarad. So this capacitor is definitely Gonski. So this capacitor is, I don't know if you see it. Oh, it's really hard to see. Oh my god, it's ridiculous. It's barely... Anyway, so it says... it's at 30 picofarads. So now we have to... After I cleaned up, now I have to clean up inside here, here and here, and also clean up flux. Then I'll try to locate some kind of replacement capacitor, because I'm not 100% sure if I have 33 microfarad 35 volts. It's something very, very specific. Okay, my friends, so I have cleaned up the places and cleaned up everything, and because it was kind of desperate to find the capacitors, I had to kind of pull my old PC power supply to get some kind of, what are these, caps cones, the even more famous capacitors. And from another VCR broken power supply, I salvaged this Rubicon. So they are 50 volt but 47 microfarad. I think 33 for 47 it's relatively okay to replace. So I'm gonna put one Rubicon, and I double test. Actually, sorry, Rubicon, let me double check them just in case. All of them. I checked their ESR, but I didn't check their capacity and stuff. Yeah, it's still not the best actually. It has 44 microfarad ASR is 2.1 ohm. How about these made from fine Chinesium? Well, all of them, maybe. Okay, this doesn't really look good. Let me try again. Okay, it was just not holding it properly. It's 45 microfarad SR2. This is actually relatively okay. I'm not sure how long it's gonna last, but it's, let me align those legs, because otherwise it would be pretty hard to hold. Okay, so this is good too. So any of those three I can use. Okay, let me prepare everything and I'm gonna solder them in place of, where are these guys? 33 microfarad, where did I put them? Oh, here. Instead of 33 microfarad, 35 volt. 35 volt gonna be sold by 50 volt, but we will increase a little bit of the capacity. So I decided to put a Rubicon capacitor in here, observing the polarity. And quite sticks out because Rubicon had deformed legs. I had to deform them back on. So let me double check the polarity. It's super important. Okay, positive is towards the heatsink. Not complaining, cooperating anymore. Yeah, this is because it had formed legs. Okay. Gonna quickly So our main goal, obviously it's a bad idea to put like used capacitors, but because I don't have any other capacitors, I'm gonna use these, you know, this, I like this one more, I guess. Okay, positive there, negative. I'm gonna use these and I'm still gonna order proper caps and I'm gonna replace them. Because this power supply is essentially unobtainium, so it just makes sense to fix it properly. Maybe replace majority of the other capacitors as well. Looks like I need to clean them up. From extra old solder. Let's try again. Is it coming? Alright. It's a very jam-packed power supply. Alright. Okay, polarity is observed. Okay. So we are in. Okay. So now we have to test it, obviously. Okay, so I'm not sure what else I can replace at the moment. So there is a big potential that this big chip is gone. But if this is gone, I won't be able to do much. Potentially those two regulators can be gone, and they are actually quite rare because they are super discontinued. But potentially I can replace them with a 78, sorry, 78 kind of chips, voltage regulators. Maybe with some optimization here. So, but for now, let's just power it up and see what's gonna happen. It's off. I'm gonna reuse this power outlet that I'm using for desoldering station. Okay. Okay, our multimeter is connected to the negative to the, how do you call it, heatsink, and very carefully. Okay, let's see voltages. So this is our ground, nothing happening. This is our ground. Oh, we have 15 volt. That's positive. We have 5 volt. What? We have minus 12 volt. We have 5 volt. This is my hands are shaking actually if you see it. Oh my god, I'm so, I guess, overexcited. I have to be super careful not to bust it even further. What is this? Okay, that's nothing. 15 volt. Let me double check. Oh my god! Stupid capacitors! Whoa! Okay, this is amazing. Actually, good news. The two capacitors, one probably was just shorted, another was like some ridiculous CSR not doing its job, was causing all this problem. I'm putting orders on the proper capacitors, obviously. 33 microfarad versus 47 microfarad, not gonna be big of a deal, but nevertheless, definitely putting the order. The only thing is another problem. I don't remember how many. What kind of capacitor? 85C. You see, this capacitor is rated 85Cs, and this capacitor is 105C rated. So this is another something to consider. Usually, it's better to put a capacitor which are rated as higher voltage, higher temperature for the power supplies because it's all cooking here. Okay, so this is good news. So let me pull everything else down and just connect it to computer. See how that's gonna go. Okay, my friends, I have connected everything, and now I'm connecting the power. Okay, I'm connecting the power, and I have a laptop here with VoiceCon. If you recognize the interface, I don't have enough space for all of this on the desk. And now the moment of truth. Okay, USB is connected. Let's see. Oh. Oh wow, it's alive! It's obviously freaking out what's going on. Let's see what VoiceCon says. LED is shining, like green here. I don't know if you see it really because it's probably too tiny. But VoiceCon. Alright guys, I think we have a little bit of a problem. So I try to do everything possible in order to, have it running under VoiceScan under Windows, but no. I have this error when so the scanner first of all get recognized by Windows 10. It presented as an Nikon LS40. But it has this stupid error message saying a system don't have enough resources to run this API or something to this extent, and ViewScan does not see the scanner, does not operate with the scanner. So nothing I can do. I try to update the firmware, the driver, but it says it's already latest driver and things like that. So I have another computer. Actually, this laptop was working with my LS 5000 ED properly, so I don't know what the heck is going on here. So I tried to connect to the same computer where the LS 5000 is actually operational, but in this kind of shape, probably it will be hard to do. So
In the meantime, I'm probably gonna wrap up. So I'm gonna order capacitors. You know, I'm not gonna assemble everything together. I'm gonna order capacitors, and then when I waiting for capacitors, I'm gonna clean up optical path here, the mirror, and maybe the LED unit right here, which is, I'm not even sure if this is LED. I hope it's LED. So we're gonna take a look at that. So this and that has to be cleaned up. So that's gonna be a separate video. So this video was actually troubleshooting the power supply and essentially checking if this unit is alive. And we see in that it is alive. If it's recognized under Windows as something meaningful, that means it's operational. So guys, I think this is going to be definitely part 3, maybe even part 4 of this restoration of this scanner. I think it's kind of interesting unit. It'll be shame to see it die. So I'm definitely gonna bring it back to life as it's supposed to be, and we're gonna definitely run some test scans with it. So guys, please stay tuned, please subscribe, stay tuned, and see you in next video when we actually finish restoring this Nikon Coolscan LS4 or LS40 or 4ED film scanner. Stay safe and ciao.